My name is Mark Ray. I'm a program manager at Microsoft. My job is to make sure that Terraform works great on Azure. So I have an engineering team that works with HashiCorp, and we work together primarily on the provider itself, so making sure that the Azure RM provider has all of the features and functionality of Azure. Not all of the features and functionality of Azure, but enables those features so you can provision those things. In addition to that, we work on the ecosystem around Terraform in Azure, so the Visual Studio Code extensions, the Cloud Shell integrations, and all of that kind of stuff. So I'm here with Eugene.
Hey guys, good afternoon. I'm Eugene Shivarov. I'm on the commercial software engineering team at Microsoft, and basically what our team does is works directly with customers to enable them in our cloud. And so the session today is actually going to be those case studies of us working directly with customers using Terraform and what we've kind of found, and giving you some artifacts to use readily, and basically hopefully you'll find this useful.
Yeah.
All right, so we're ready to kick this off. You want to go over what we'll cover?
What's that?
Do you want to go over what we'll cover, or should we do the Pong redo?
Do the Pong first.
All right. How many of you guys have been in the morning session, the keynote? Show of hands. Perfect. So we had a little hiccup there, right, with the Pong. Didn't quite work. So we kind of just, Mark and I, we decided to maybe we have a chance to redo this thing really quickly. So we need 2 volunteers from the audience. Any hands? Show of hands. Come on, guys. 2 volunteers really quickly. OK, 1, 2. Come on up. Really quick. We only have 35 minutes for a whole session, so let's just do this really quick. So we have these guys. If you guys have been at our booth, this is our open source mascot. So you stand on this X, and you stand on the other X. You stand on this other X. And so you guys pass this around. Throw it to him, and you throw it back. OK, very good. Now do it again. Do it again. OK, very good. Now do this. Here's you, the Pong. Here's you, sorry, the Brady's. Give me 3 more. And so now you throw it in the audience.
We're going to get fancy.
So it's giveaways, guys. Just take this home. If you want the Brady's, if you like them, stop by our booth. Stop by our booth downstairs. Fill out a survey, and you can get one of those too. Ah, he didn't even want it.
All right. Thank you, guys.
Give them to.
Yes.
Thank you for your participation. Pong worked this time. Oh. It wasn't cloud-based, but hey, sometimes you got to do it. All right, thanks, guys. So let's get on with our session. So you want to talk about what we'll cover?
Yeah, so we're going to go over a few different case studies like Eugene mentioned. We have a couple of customers that will talk about how they're using Terraform in their deployments to Azure. And we'll also talk about some tooling that you guys can actually download and use based on best practices and things like that for deploying Kubernetes to Azure, essentially. So we'll go over the Project Bedrock, which is that tool set that you can actually download and use. We'll talk about Axon. And then Oracle, and then we'll kind of round up with Azure DevOps and how you can use that with Terraform and integrations and stuff like that.
All right, so let's kick this off by talking about Project Bedrock. And also, guys, you have a chance to win Brady's more. I'll just ask you a question. The first person to say Azure word gets one, OK? So let's go ahead and start with Bedrock. So what is Project Bedrock? As I mentioned, I'm on the commercial software engineering team at Microsoft, where we work directly with some of the largest customers that you can imagine on our cloud. So this is a set of guidelines that we have put together to allow our customers to basically provide or build the enterprise-grade Kubernetes deployment in the cloud. So, OK, who said that? Here you go. There we go. Oh. Do a redo. OK, that's fine. So it's used in the GitOps workflow. So all those buzzwords means that basically if you today are looking at doing enterprise-grade Kubernetes deployments, you can use these guidelines, which are open source. And we have iteratively worked with our largest customers to build out to get a head start on that. So what are the basic principles of this Bedrock project? So leveraging cloud-native momentum, we're going to provide you a set of guidelines to deploy complex microservices into the system. It's going to use Azure Kubernetes Service, and we're going to capture best practices for actually deploying Azure Kubernetes Service into the infrastructure on Azure. So the critical piece here is that we use real-world experiences to build these guidelines out. And again, used by Microsoft customers. That's the URL of it. You can certainly also Bing for it or Google for it, whichever you prefer. Project Bedrock on Azure. So those are the main components of Bedrock. And certainly there's Kubernetes. There's a Terraform piece, which is really why it's important for this session. So it uses GitOps principles. And those are the three topics that we will cover, I will go over shortly. And the other two are also very important, which I will leave it to you to discover on your own. So why am I talking about this specific project here today to you at a HashiConf conference in a session on Terraform? Well, the most important piece is that we provide you a set of templates that you can readily deploy today as part of this project. So as you probably know, most of you know, Terraform provides a declarative way to deploy your infrastructure. What we package as this project is a set of predefined templates, a set of pre-configured environments for common enterprise scenarios that we see today. It also includes multi-operator support. So pre-configured templates today include Azure single region deployment, Azure multi-region Key Vault, and a couple of projects we're working on today. So as part of this deployment, you get global redundancy out of the box. So essentially, today you can do Terraform, plan, and apply, fill in certain variables, and get this readily enterprise-grade Kubernetes environment in your subscription. So for example, one of the examples of global redundancy would look like this. You would have an API management server and a traffic management basically service deployed. And then you have two regions in Azure with application gateway with Kubernetes clusters running in each region. And then certain software pieces deployed for you that kind of allow you this GitOps enabled Kubernetes cluster configuration management. So let me just swap into Terraform code really quickly to just show you exactly what you get as part of this project. So here's the VS Code. Once you clone the repo, you get a set of Terraform templates, as I mentioned. So if I open up a cluster, go to environments, you can see there's multiple environments we provide here. If I look at main.cf, you can see that we reference those modules from the GitHub repo, which means you can copy them locally. There's no dependency on any particular piece or any particular file, any particular folder in this. You can just copy it and kind of work with it from within your environment directly. So you can see we deploy a basic virtual network and then provide a set of variables to actually provision an Azure Kubernetes service cluster, which will be the first step in your enterprise-grade Kubernetes deployment. So that's Azure Simple. You can see we try to modularize everything, but also a very important piece that I wanted to mention here is with Terraform 0.12 announcement just a few months back. Certainly, we're breaking changes between versions. So if you use 0.11, you cannot necessarily kind of just use 0.12 out of the box and everything works. So what we decided with this project after several conversations is we decided to do separate releases. So there's a separate release for 0.12, and there's a separate release for 0.11. So those customers who are still standardizing on the earlier versions of Terraform are still able to use this project. However, for newer deployments, we're leveraging 0.12. And this strategy has worked out fairly well for us. So if you're considering potentially switching or deciding between 0.11 and 0.12, we decided that all the future investments of our efforts in this project will be based on 0.11 version of, 0.12 version of Terraform. And this has been working fairly well for us. So I realize I am probably running way over on this project. So let me just cover a few other important pieces that we provide. So certainly, kind of like the main point here, we provide you a set of enterprise-ready Terraform templates to provision Kubernetes infrastructure in Azure. But also, after you provision this infrastructure, this deployment allows you to operate with this infrastructure easily using the GitOps operating model. So just a side metal note, probably already know this, Kubernetes declarative system, specified set of resources, and then Kubernetes kind of works to figure out exactly how the infrastructure should look like. So textual manifest declares the desired state. So what that means is if the declared state if we can declare a state via a sort of source files, we can have this piece of software, and this piece of software being the Weave Flux that kind of pulls the state of the system, or what it should be, and reconciles it with the current state. And this is where the GitOps workflow it becomes enabled. So the GitOps operation by pull requests, so to speak, works in a manner that developers or operators would submit a pull request of how the Kubernetes infrastructure should look like. The in-cluster daemon watches the repo and reconciles the state of the world, Kubernetes world, of what it is today with what it should be. And so all of this is basically enabled via this project, Project Bedrock. I'm way over time here on this particular case study, but basically, hopefully, you get the value of GitOps. I mean, it's a declarative code, operation via pull request, provides you a history, source control, all of those things you get out of the box if you kind of follow the guidelines that we provide for you. And just kind of recapping what it is. With Bedrock, we provide you an easy-to-use Kubernetes deployment. You get sort of like GitOps workflow out of the box. There's a custom language that we use called Fabricate. Sort of allows you to higher level specification of Kubernetes configuration. You don't necessarily have to use that if you don't like. And then also we deploy some service mesh capabilities together with that. So hopefully you use this project or at least take a look at that. See if you're in the very beginning of your enterprise Kubernetes journey, it could provide you a good set of guidelines. If you're somewhere in the middle, hopefully there's still some good value that you can derive from that. So over to you, Mark.
All right, so now we're going to dive into a little bit on a very interesting customer use case that we have worked with that had success deploying to Azure with Terraform. The company is called Axon, and I'll just spend a few minutes here talking about what Axon does because it's really kind of interesting from my perspective on what they do. And their whole philosophy is around building devices and software to protect life. So they work with the military, they work with police and things like that to develop things like tasers and body cameras and stuff like that to actually ensure that not only are they protected themselves, but that they don't need to use lethal force when dealing with bad guys, if you will. So they, as you can imagine, where they have body cameras and things like that, and these videos have to go somewhere, there's going to be tons and tons of data that they collect. And when they collect all of this data, just collecting that data and sticking it somewhere is not going to be useful at all. So they have ways of actually using AI and things like that to reason on this data so that they can use it for evidence in court for the police officers and stuff like that. So there's lots of cool stuff that they do there from that perspective. And they deployed to Azure for a number of different reasons. They migrated to Azure from another cloud, I think, or on-prem or something like that. But they ended up migrating 20 petabytes of data over to Azure, so it's a whole ton of data. And they're actually collecting 2+ petabytes of data each month, so that amount of data is just growing and growing and growing. And what they really like about Azure is that the storage just seems endless to them. They don't need to think about it. They just keep shoving more and more data up to Azure, and Azure just keeps growing. So that's a really great thing from their perspective. In addition to that, they like that it's global. So they have customers that are worldwide, so they can actually deploy to any number of different regions and take advantage of that and not have to worry about whether they obviously don't need to build a data center or anything like that, but they just can go where the customer is and make sure that that's there. And the last one is data governance. So as you can imagine, all of this PII kind of data, they don't want that to get out, so they have strict governance that they apply to that, and they're relying on Azure to be able to do that as well. So from there, from what they do from a Terraform perspective, they actually use Terraform to deploy new services, and those services, at least when they started out, were made up of a virtual machine, they had storage, and they had network and stuff like that. They deploy to the different regions. They deploy from the commercial cloud. They deploy into the government cloud. And they've grown since the initial deployment to actually adding things like configuring functions and logic apps and other first-party Azure type things. And they're deploying all of that stuff using Terraform. So a couple things to touch on there. So they have had a great experience with it. They use Terraform because they can do more with less. So it makes things less complex. They don't have to worry about manually writing scripts and all of that kind of stuff. And it's taken their time to deploy down significantly. So when they were doing it using scripts and manually and stuff like that, it would take weeks, and now they're taking it down to hours. So they're really getting a lot of benefit out of both Azure and Terraform together. So with that, it has not always been sunshine and rainbows. Has everyone heard of what that saying means? Sunshine and rainbows. I'm sure you can imagine what it means, but it has not always been super smooth for them. They started Azure. Perfect.
Sunshine and rainbows.
Yeah. Sunshine and rainbows. Azure. So when they started out a 1.5 years, 2 years ago, deploying to Azure with Terraform. And they have worked very closely with our team as well as HashiCorp to make sure that they had the coverage that they needed. So it was a bit painful to start with, but they worked closely with us and we worked closely with them to make sure that they were successful. So that is something that we're really proud of, that it's not always gonna be super smooth and things like that, but you're working through it and you get the stuff done, then it turns into this project where right now, they can deploy any new software, any new service, any cloud environment, they can deploy very quickly and easy using Terraform. So let's talk a little bit about what their environment looks like. I'll show you kind of conceptually here real quickly, and then show you some pieces of the code. So they started out because they started out a couple of years ago. They started out on 0.11. Their new services and things like that, they're moving to 0.12. But the structure that they use from a Terraform perspective is interesting, and I'll show you the code and how they lay it out and stuff like that. But they essentially make use of a bunch of modules. They have their own modules that they build for doing things like configuring NSGs and configuring the network and configuring load balancers and all of that kind of stuff. So they have modules for each of those things that take advantage of their best practices in the organization and all of that kind of stuff. And then they have a central configuration that builds on those modules. And then they have variable files that they use to actually for their different environments. So all they do when they deploy is use a different variable file with the same config, and everything just works magically. They use Jenkins at the core of that, so that's their orchestrator to actually take the files and deploy those things. They also take advantage of Packer. So they have a small set of images that they use instead of building a different image and doing complex configurations and stuff like that on their machines. They build a small set of images, and those images are used in their VMs when they deploy them. And any configuration that they need to do after the fact, they use Cloud Init to use a simple configuration to do that stuff afterwards. And they've also built what is really intriguing to me is a shell script. So what wraps all of this stuff up is a shell script. So Jenkins is actually running that shell script to do everything from plan to apply to actually pulling state in and all of that kind of stuff. So all they're doing is calling a simple shell script, and that does things like connecting to the remote backend and all of that kind of stuff too. So all you have to do is say, run this thing, to send it to this environment, and it goes and does it. So it abstracts a whole bunch of that stuff away as well. So it's kind of cool how they did that. They're using Azure RM backend for the state. So they're storing that back there and restricting the permissions so people don't have access to that and all that kind of stuff. And they're actually deploying to Azure itself, the VMs and all that. So from there, let's jump into a quick demo to show you what their code looks like. All right, so I will have to reconnect here. So I'm going to show you a couple of things here. I have pulled, it's not their exact code, but it's a model of how they actually save their code and stuff like that. I've actually pulled that up into my Azure Cloud Shell. How many of you guys have used the Azure Cloud Shell? Okay, looks like about half of you. So the Azure Cloud Shell is just a command line, either PowerShell or Bash inside of the Azure portal. So you open that up and you have access to everything in Azure. And what's nice about it is a lot of tools that you need for infrastructure management are already there, including Terraform. So you open the Cloud Shell, Terraform's there. If you run I can spell. Doesn't know what version is.
Gotta remember the live demo thing, you know.
Yes.
Those guys are not
so that's there. It's the latest version. We actually update on a regular basis. Every time the Cloud Shell is updated, we get the latest version of Terraform. So it always has the latest every 3 weeks or whenever that thing is updated. So if I go into...
If I just made one... So I guess I think if you guys haven't worked with Cloud Shell, the cool thing about it is like literally you log into Azure portal, click the Cloud Shell button, you automatically authenticate it, ready to provision infrastructure. And it's great for sort of like ad hoc development efforts or just iterating on something. So that's very nice.
Yeah, and you can have access to that from Visual Studio Code as well. There's actually a plugin for Visual Studio Code where you can actually get access to the Cloud Shell right from within Visual Studio Code. So this is essentially their setup that they have from a configuration perspective. Within Terraform, they have that script that I was telling you about. And if I...
But it also looks like you're showing a Visual Studio Code interface built in.
Yes, I am. And you'll see here in a second that we have IntelliSense and stuff like that in there. So if I come into Terraform here and just do a tf deploy /. You can kind of see some of the options that they have. So it's simply when you need to run this, you tell it what you want to do. You want to plan, apply, destroy. There's some defaults for that and the environment where you want to deploy it to. And it's going to take what's in this main folder here and run that configuration. So that's just a set of configuration that's broken out into their individual consumable pieces that take advantage of the modules that are over here. And then they have this deployments, has their different environments in there in the tfvars file. So the tfvar file just has all of the different variables that are passed into that configuration itself. So it gives them a lot of flexibility if they're going to deploy to another cloud or whatever. They add a new tfvar file, run that script, and it just gets deployed. They obviously do all of that through Jenkins, but you can see conceptually how they do that there. And just so you can see here, pick a good one. So in the Cloud Shell itself, we have the code editor in Cloud Shell. We have good syntax highlighting and all that kind of stuff. So you can actually, if you need to make changes to the code, you can come in here and make the changes in a really efficient way as well. So, and with that,
You mentioned you will show Cloud IntelliSense really quick? No, that. Only if you feel like it.
I don't think we need to, yeah. So we'll jump back to the slides here real quick. And I'll hand it back over to Eugene.
All right, perfect. So that was Axon. And the next customer we're going to talk about is Oracle. Any of you guys know what we did with Oracle? Totally improvised.
Say Azure.
All right, who said Azure?
Here.
All right, you can
I get to throw. You talk.
Now, so basically, I know a couple of you guys raised their hands. You probably kind of meant to say this. Microsoft and Oracle link up their clouds, right? So today in the keynote, we kind of saw how you could link up the VM cluster with the AKS cluster using console service mesh gateways. Well, how about we take it one step further, you know? Why don't we just link up the two clouds? So there's Oracle Cloud, and there is Microsoft Cloud. Got a little bit of coverage at TechCrunch. That was probably 3 months ago. So why would we do that, right? Why would we link up to two clouds? And so the idea is to let the best cloud do what they're best at, so to speak, or so let each cloud do what they're best at. So for Oracle Cloud, that's about managing Oracle databases. It's about management, patching, et cetera. For us, that's running our applications, running our infrastructure on top of Oracle. So if we link up the clouds in some sort of a very fast fashion or way, we should be able to actually provide you the best of those experiences. And so the idea is use kind of like the private backbone, the private infrastructure backbone that allows this high-speed connectivity. And so why are we talking about this here in Terraform session? Well, of course, when we talk about linking different clouds, the most natural tool of choice that comes to mind would be Terraform, because Terraform is multi-everything, as you've seen in the session this morning in the keynote. So couple of quick points there. First time any cloud provider has done this is linking two clouds. So why did we use Terraform? So clearly, multi-cloud, cross-cloud deployment model. Both companies can speak Terraform. So we speak Terraform. Oracle certainly speaks Terraform. We probably speak very few other languages together. So it allows us to iterate quickly and with a community involvement. Community involvement is critical for us. We welcome community contributions. If you guys contribute to Terraform provide for Azure, for our modules, thank you very much. Please continue doing so. Open source. Terraform is open source. A lot of issues we run into are out there in the open, and there's a chance somebody will pick it up and help us solve the issues. So as a result of those efforts, you can actually do a few things in Terraform via the open source model that you cannot even do with PowerShell, Azure CLI, just because somebody jumped ahead and said, this particular piece of functionality, we're going to go ahead and address that. And as a side note of why linking the two clouds is integrated identity and integrated support, where customers can dial in one number, one support number, or reach out one support, alias is very important. So this is what the basic architecture of the solution looks like. So the blue is Azure, the red is Oracle. So as I mentioned before, in Oracle, you have the database tier. So the Oracle actually manages this for you. Basically, your database resides in Oracle Cloud. And then via high-speed connectivity, you're able to talk to those little figures in blue there, which is the app tier, and the network gateway that enables this connectivity model. However, looking at this diagram now, I'm just thinking from this morning or just in general, certainly there's an opportunity to potentially evaluate the service mesh application, the service mesh gateways, and just to see how they perform relative to the configuration that we have today. Because in this infrastructure today, you have to be very careful about planning your address space. So the address space in Oracle Cloud cannot overlap with the address space in Azure. And this certainly requires the coordination and planning on both sides, something that could be eliminated if we used console today. So that's definitely a project for the future. So the components overview, the Azure OCI Cloud Interconnect, which is just really the basic networking pieces that allow the clouds to talk to each other. And so in addition to just the basic interconnect, we're releasing, we actually already built them out for the most part, but we're releasing in the open source the scripts to provision Oracle applications in Azure. JD Edwards and e-business suite are going to be added in this repo that you can also search for or just go there directly. All right, I'm just going to show you a quick, just go step through the code really quick. So steps through the Terraform code that enables this connectivity. So this is Project Bedrock. We're going to switch to a different one. So all of this is open source again. You can git clone and have this all available to you. And in the ideal world, all you would need to do is just clone this repo, run Terraform apply, and everything is certainly provisioned for you. Unfortunately, we're not quite there yet because the connectivity pieces have to have on both sides. So from the Azure side, so you can see how, here's interconnect step 1. And here, basically, is a step 1. You can see it's just a very simple setup procedure. I should say setup, very simple from the Terraform standpoint. It's a fairly complicated thing to set up. You set up what's known as Azure Express Route Circuit. So the Express Route Circuit is something that will enable high-speed connectivity via a private backbone with Oracle Cloud. So once we run this Terraform plan and apply, we have an Express Route Circuit set up. So the Oracle Cloud, on their end, they have to provision their high-speed connectivity via Oracle Fast Connect. When this linkage happens, that's when you have the high-speed connectivity available to you. So you can see this step is automated via Terraform. Oracle needs to come in on the back end and do it manually a little bit at this point. So once this happens, the circuit becomes complete. And then, so it's a step 2 here in interconnect. All we're doing is setting up the additional pieces of infrastructure additional piece of Azure-specific infrastructure that allows this connectivity to be fully realized. And this is Azure RM, Azure Virtual Network Gateway, and the public's IP being set up. So once these 2 steps are completed, then the connectivity is established, and it's sort of like this magic of really linking up the two clouds is realized. So that's, the main point there is certainly Terraform allowed us to do this. It allowed us to talk the common language, allowed us to link up the clouds. I'm not saying it wouldn't have been done by any other means, but it certainly would have been a much more difficult conversation to have. So we have 4.5 minutes left. I just want to ask you a question. So, all right, so I'll pass those out, and if you want to just cover the Azure DevOps piece.
Yeah, so we just wanted to talk to you a little bit about Azure DevOps. Like I mentioned before, I'm part of a team that focuses on making sure some open source software works well with Azure. So products like Jenkins and Spinnaker and Ansible and Terraform are all products that we make sure work well. That being said, we do have a first-party CI/CD solution that a lot of Microsoft and other customers use. And I think one of the things with Azure DevOps that I don't know if a lot of people actually know is how cloud agnostic it is. It obviously runs in our cloud, but it can deploy to any cloud or on-prem or anything like that just because it runs in the cloud. If you have access to your on-prem, it can deploy there as well. So there are a lot of great things about that. So from a Terraform perspective, a lot of customers that use Azure DevOps or a lot of customers that use Terraform with Azure want them to work well together. There are a number of different projects on adding extensions to Azure DevOps, so you can actually use Terraform easily with Azure DevOps. And some of the things that those extensions do are things like setting up your remote state easily for you and allow you to save the state there so it's in a secure place. One of the things that you'll get into from as soon as you start using Terraform in any cloud is making sure that you deal with secrets correctly. And a lot of times you have a chicken and egg problem where just to get set up, you need to have a secret somewhere, where with Azure DevOps, you can use a cloud connection where you can actually get that set up so people can just create their pipelines and do their deployments and stuff like that. So that kind of bootstraps that bit as well. But Eugene's going to show how we actually use Azure DevOps as part of the Azure modules deployments. So when any employee of Microsoft creates a module that we're going to release, a lot of the field folks and things like that working with customers create Terraform modules. We have a pipeline that goes through and runs tests and things like that for those modules so that we can release them to the public with confidence and stuff like that. So.
Certainly, and I wanted to make a quick point that since our team works directly with customers, there is, so essentially Azure DevOps or DevOps tooling or CI/CD tooling of some kind always factors into the conversation along with infrastructure as code. So most frequently we use Azure DevOps for that just because I guess, well, first of all, of course, it's a first-party product. Second, the amount of just free stuff you get with Azure DevOps is very significant. So you can have, I mean, actually, it's on this slide, and you can just actually produce, you can look it up yourself, but there's unlimited repos, private repos that we give you as part of Azure DevOps for open source projects. Will allow you to run continuous builds, and then up to, I guess, have to look up exactly the number of contributors, but up to a certain number of contributors in GitHub repos also are free. But here, we only have 1 minute left. I just want to briefly mention, this is what the interface basically looks like. This is the demo we're running downstairs at the booth. And so, as you can see, sort of like there's a YAML pipeline that defines the basic stages of the build. So we define some variables, they set the staging state, and they say, hey, this YAML pipeline will actually control what gets released. So how does this pipeline, how does this YAML look like? So I'm just going to switch to that's actually what the YAML looks like. And here in the steps, we have, what's important is we have a Terraform task. So everything is in Azure DevOps is centered around tasks. So there's a Terraform task that performs basic things for you. In this particular case, it says Terraform init. We pass in certain things, certain variables, initialize Terraform. Then the next task, also Terraform task, does Terraform plan, where we also pass in some variables and get the output back. And then finally, we do the Terraform apply, also via that tasks. So that as a result of this deployment, you will actually have infrastructure deployed to Azure in your subscription. Out of time, but this is the demos we're showing downstairs. But as Mark mentioned, we have also adopted the similar approach for actually testing the modules that we develop. So many of you are probably familiar with Terraform registry. So before generally we try to stick to that, and I know we could do better, and we should do better. It's actually introducing the testing for all the modules we release. So what you can do is, as part of the Azure DevOps, we're not deploying any infrastructure, essentially. We're writing a set of tests that we're executing in a Docker container against basically the infrastructure we define, and we provide the output of succeed or fail. So that's also available sort of via Azure DevOps, and I can definitely go in depth on how we do this at our booth downstairs. So thank you guys for coming. We're out of time.
If you have questions, come see us at our booth if you want.
If you want a Brady, you can come up here, but you have to say a magic word.
Yeah. Thank you, everyone.
Thank you.
All right. Thank you.